Hello, and welcome back to Modern Software Management, modsoftman.com on the web, channel name @modsoftman on YouTube. This is a very important video. I've just uploaded onto my website a practical example of a Horizon plan. As you'll recall from episode 1 and then into episode 2 a little bit as well, it's the methodology I use when I go into a software company to manage the software projects. So what I've done is I've uploaded an example, really practical Horizon plan that you can download, use it as a template, and apply it to your software projects as well. Over here is the website, ModSoftMan, Modern Software Management. You'll see there's a number of sections on this. The Resources tab is important. On the Resources tab, you can download my textbook. So textbook is 396 pages that I use to teach my software engineering course. It has sections about Horizon planning, about the kind of theory underlying it, the capacity constraint, both quantitatively and qualitatively, some of the statistics involved as well, how to apply it to cloud-based software and software releases and versions and so on. So that's a nice resource for you, entirely free of charge. Just download it. There's a little intro here to Horizon planning, which talks about the benefits of Horizon planning, in a list here, and it talks about the steps involved in Horizon planning as well. And then what I just uploaded yesterday is the Horizon planning spreadsheet. So you can just go in and download it from here, utterly free of charge. And you can download a document that is exactly the same as the page that we're looking at now. And the page we're looking at now explains all of everything about how it works and explains the meaning of every field and so on, which I'll go and explain some of that to you now. So here it is in its overview. There are 3 tabs on it, but this is really the most important tab, the Horizon planning tab here, and it's the key tab. So let's zoom into that. And so this is an example. It's based on some practical real-world examples. It's extremely typical of an actual release plan. I call it a release plan in the sense that this particular plan is for on-prem software. So software that comes in distinct releases. The releases are maybe about a year, 9 months to a year apart, because the customers, these big enterprise customers, don't want to take major releases any faster than that. And so there's a time during which you code and test and add automated tests and integrate continuously, called the coding phase. And then there's a phase after that called the stabilization and validation phase, because the software gets installed into so many diverse customer environments and there's so many possible upgrade paths. It's run on so many different platforms. It requires a lot of back-end testing, and there's a lot of complexity involved in that. So it has these extra phases of stabilization and validation. If this were a SaaS-based product, it's simpler. You just don't have those phases. You just do all of the work within the so-called coding phase, and you continuously release your features to production. So it's a very similar plan, just doesn't have those 2 extra phases. And I'll do a video later on explaining a little bit more about the difference between those 2 things. But for now, this is for enterprise on-premises software with relatively larger release cycles. So we can see here, the planned start date was April 4th. So that's when the developers really left the previous release and jumped onto this release. And it doesn't happen all at once. So this is a bit of an artificial date where, it's really starting to happen in a big way. The planned delivery date on this, the target release date, is about a year later on April 17th, 2023. And we are currently looking at October 3rd. So we're most of the way, a lot of the way anyways, through the plan, through the development phase. So we see between April 4th and October 3rd, which is the day this plan was updated there were 121 work days. And work days are, Monday to Friday weekdays. And then you remove out of those weekdays these holidays. So you just use a function in Excel that removes those holidays. You can see the little computation up here, net work days between those two dates, taking into account that holiday schedule. So 121 work days elapsed, and we have 36 work days remaining until we get to the targeted end of development. So that's the decut date. Decut is development cutoff, is the date when there are no more code that any of the developers are aware needs to be written to be done. And what does done mean? Done means that you've coded the feature completely, you've coded all your error cases, you've coded any monitoring software that you need to go along with that, you've coded any deployment software, you've coded any automated regression tests that you're going to be adding. You're basically done. Done and dusted, and probably demoed it as well. So this is the point at which no developer is aware of any more code that needs to be created. Now, there will be some more code because errors will be identified later on. But at that point in time, it's a very binary thing. They're not aware of any things that need to be added. So we're aiming to November 24th. We're at October 3rd now. And, are we on track for that? I'll get back to that in a moment. After this, there's this stabilization phase, and then there's a validation phase. So the stabilization phase is 79 workdays. It's designed to be, if we look at the formula, it's designed to be half the number of workdays as between this date and that date. So if the release is shorter, you need less time typically. If the release is longer, you need more time for stabilization. If you're going to extend the release date, you also extend the stabilization time. They go hand in hand according to this formula. And then this extra day is just 20. It's a constant added on the end, which is overhead to release any release. And so those two get summed together, and the final end date is computed over here by adding that number of work days, taking into account the holidays, to this date. So we then look into this section to see if we're on track for that. So I beeline to this thing, the 78%. 78% means that I only need 78% of my capacity, my remaining capacity, to achieve everything that needs to be achieved. So that's pretty good at this stage in the plan. Earlier in the plan, I'd like that more to be like 70%. But as we're getting nearing the end and the uncertainties are decreasing, 78% looks okay. Where does that come from? Well, we look at the remaining capacity over here. We have 365 effective coder days of capacity. What's an effective coder day? That's 8 solid hours, 8 ideal hours of doing this coding activity, of individual contributor work by a coder. So those are 8-hour chunks. We have 365 of those 8-hour chunks amongst there are actually 30 people on this particular team in the 36 days remaining. An estimate of the remaining work we need to complete is 285 ECDs. So very compatible units, same units. So we see we have a positive delta of 80. So positive is good. Negative is you're in the red. It's bad. Something needs to change. And the ratio between those two, 365 and 285, is this 78%. So that says I'm on track. While there are 285 ECDs estimated left, we've actually accomplished 1,109 ECDs to date. So that was actually logged time. I advocate all the devs do detailed time tracking using Jira of every ideal hour they spend on every feature in the plan. And that they've logged the time and has come up to 1,109 so far. Going forward, what I call big N is 10.1. So 10.1, it means on average, we're estimating that we have 10.1 ECDs per workday of capacity for the remaining 36 workdays. Now, here's a little check on that. We look at the N actual. So in recent history, and I'll explain what recent is in a moment, we've been averaging about 10.3 ECDs per workday. So that's good. That means we're a little bit ahead of plan. We got a little bit of buffer there, and we have a little bit of buffer in the 78% as well. So we can go over and look at these charts as well. And I love this chart. This chart was actually first introduced by a colleague of mine named Matt Medland when he was applying the system, and I've shamelessly borrowed it here with attribution. But this is basically a burn down chart where at every given, well, if we look at the current date and time, this is just those numbers you saw on a chart. So the blue line is the estimated remaining capacity. The green line is the estimated remaining requirement for what we call the A-list features. The A-list features are those that they define the meaning of the release. We really want all the A-list features in. On top of that, we have a B-list of features over here that, as you see, we can't possibly accomplish all of them, but hopefully we can get to some of them. Devs are allowed to work on B-list features once they have nothing to do on any A-list feature anymore. So we can create a little bit of a buffer. That's that 80% buffer in here, but still not run out of work for the devs. And the second thing I look at is the trending down of that green line compared to the trending down of the blue line. And it's pretty good. They're trending pretty well in parallel. Maybe this one is cutting up a little bit, but it looks like they'll converge towards the end date approximately. So that's good. That means things are on track. Our estimates have been more or less correct. You can see a bit of nonsense, of course, at the beginning. When we first started the plan, we knew some of the things we wanted to work on, and we had some of the developers starting to work on them, but the plan wasn't fully formed up. So these big jumps are cases where we collectively decide, the stakeholders collectively decide to add things into plan, trying to get all the way up to the capacity, or 70% of the capacity on the A-list. So that goes on for a while, and we see some burning down, and these will include some burning down as well. So we've got some burning down going on over here that we're working on things, and then something new gets added to the plan. And you can imagine the discussions that happened back on this date. It's like, well, we only have this much capacity and you've just added this extra feature. So that's impossible. Product management, what are you? You're on crack. So they say, okay. We'll take out some of the features. We'll lower the scope, and we'll also increase the end date. So a rise like that is typical of a change in end date, where because we've moved the date further out, we've increased the capacity, of course. And so now at this point, we've got something that looks okay, decent, not that 70% I want, but close. And then product management came and added another. No, we absolutely need this. And we said, okay, guys, we're in trouble. We can't possibly. And so there are a lot of negotiations, and they remove some stuff from plan. And meanwhile, we're still working on stuff. And then we arrived at this point over here where, again, these two match and say, no, we need 70%. So we moved the date a second time, and now we're in pretty good shape. And then that persisted. Some of these smaller changes are developers re-estimating their work factors. If they're going up, they're saying, yeah, I'm actually doing a few more ideal hours per workday than I thought, so I'll just change my estimates. And so those go up. The fact that it's a bit wiggly is because of weekends and holidays generally, things like that. And here's like another estimation up of work factors. Hey, actually, we're getting a lot done. The lower chart over here, the achieved work factors versus current prediction. Again, it gives us some comfort that we're on track with our estimates of how much work we're doing per day. So the blue line at any given point is our estimate. And occasionally we move the estimate up, and then occasionally we move the estimate down and go on. But this one isn't affected by changes in end date. This is the instantaneous daily estimate of how many ideal hours across the team per workday we can put in. Red is the actual that's logged. So what you do is basically every day time is logged, and we average that out with an exponentially decaying average. And so that smooths it out a bit, because what happens is is a manager will notice, for instance, that a time hasn't been logged recently. They'll go back to a team member and say, hey, you haven't logged your time. And the team member says, oh, sorry. They go back in, and for the past week, they fill in all the time they actually did into Jira. And suddenly, on a single day, it kicks way up. But that's really should be smushed over a week. But our tools don't have the ability to capture that correctly. So smoothing out works as well. So you can see here, as we were rising, we re-estimated the work factors up. But then as the work factors were falling down to here, we re-estimated them down. And now they're matched. And then gradually, though, we were doing a little bit more work than that. So we re-estimated them up, which brings us to the current moment over here, where they're very equal to one another. They're very close to one another. So that's great. So great. This plan is in shape. What's it in shape about? It's these A-list features over here. So this is the A-list features and the B-list features. So each one of these will normally be references to like a Jira ticket or whatever your work tracking system is. There'll be the short description pulled from Jira, which will be a bit indicative of what it is. I categorize each of the features into buckets so that the company can have an understanding of where the effort is going. I'll get back to that in a moment. We assign these things to various teams, and we have a number of teams. We have 3, 4, 5, 6, 7 teams in this particular plan, and each team comprises several individuals. So that would be a typical 5-person team, for instance. I'll get back to that in a moment as well. We pull the status from Jira. Are we fully done? Are we not yet started? Is it in progress? Is it ready for verification, ready for demo? Those are steps, workflow steps inside our Jira. Inside your Jira that may differ, of course. And very importantly, this is the ECDs done to date. So this particular feature, 65.63, has been recorded of ECDs. So remember that's times 8, that's ideal hours, has been recorded. 1 ECD is remaining. Here's a not yet started one where 0 ECDs have been put in and 20 ECDs are remaining. And here's a bigger one, which is 177 have been done and 110 are left. So you say, oh, well, wait, these are too big for stories. Yeah, they're not stories. We call them features. So they sit at the top of Jira. There's features. We then have, I think, goals and epics and stories and potentially tasks underneath that. So this is grouping. Generally, we don't use goals so much. We use features into epics, and epics are divided into stories. And some teams use tasks and some teams don't use tasks. So it's a big agglomeration that makes some kind of a business sense to either include the whole thing or take out the whole thing. You can also, consider reducing the scope of something as well as an intermediate. But they're things that, anyone in the company would be able to look at it and understand it. Oh, I see what that is. It's not little technical things that there's a huge laundry list of 2,000 of them that you think, oh, that's more information. No, that's less useful information, right? This is just the work has been done to summarize these things into business meaningful chunks of things that you work on. So this is the current list of everything that's expected to be on the A list, and likewise for the B list down below. We group them into these various buckets over here. And again, these buckets, you change their definition according to what makes sense to you. The most important one, and 60% of the time, is spent on product management initiatives. So there's things to make the software more saleable, more marketable. And this number is the sum of what's been done plus what's left to be done on any feature that's been assigned that category. And we had a customer service bucket, which was a bucket that could be allocated by our customer service team to ask for features that were either useful for them to help them, debug issues at customers, or that some of their top customers really requested that may not be that generally marketable, but are very important to individual customers. There's a bucket, makes up 16%. The classic tech debt bucket, where we don't change any of the externally observable behavior of the software, except maybe make it faster. And we remove dead code and we refactor code. And we also have a category called business basics, which is things that just have to be done to maintain the software, like move to the latest versions of various libraries, or the latest version of the database technology we're using, or the latest version of the operating system. And so anyone can take a glance and say, well, is that appropriate? Kind of agree on the targets for these percentages ahead of time, and this is what it actually is. Sum of this, if we look at the sum of the ECDs to date and remaining, the 1109 and the 285, that should be familiar because those are just the numbers that are brought up here. The 285 is the A-list requirement remaining, and the 1109 is what's been accomplished to date. We look at now developer capacity. Developer capacity is where we compute the remaining capacity in ECDs, this 365 over here. So let me open up a team, and each of these teams has team members inside it, and they're all similar to this one. So we list the name of the person. This would normally be the actual name of the person, and maybe in brackets the role. Like this one is a team leader. This one is also, say, an architect. Well, this one happens to be an intern. First number is their availability. Are they 100% available for this project? Like, are they not working on something else? Sometimes we do like a 50% if we have to divide them in two. This is the amount of vacation that they estimate they'll be taking from as at until DCUT, November 24th. So that's not a very vacation heavy time. So most folks have used their vacation during the summer, and they're not anticipating taking any more vacation. So it's an estimate of vacation. This is the estimate of their work factor. So this is the estimate of how many ideal hours per workday they're estimating they're targeting to get in for these remaining 36 work days. So devs are encouraged to change those whenever they believe the situation has changed. They have tools where, just like on this graph, they can look at their own personal work factor and say, yeah, I'm not near it. So that's how these things tend to converge, because individuals will look at that and say, yeah, let me adjust it because it's not quite what I said it was. And so the units, ECDs per workday. So the team lead expects to do 0.2 ECDs per remaining workday. So 0.2 ECDs times 8 is 1.6 hours of dedicated coding. And because they're a team lead and they do half managing, half coding, and half helping out other people, they may be relatively lower. Often upper management will question these numbers. Well, they're only working 45% of the time. No. First of all, it's an unrealistic 8 hours of solid coding, right? So nobody does that. This is only individual contributor time. So any time spent in meetings, coordinating with other people, any time spent seeking help or giving help to other people on the team, none of that's included. If they're ill at any point of the time, that's deducted from the measured work factors as well. If they're fixing a bug, triaging or fixing a bug that was reported from the field, or helping a customer service person, that's not included in this time as well. If they're maintaining the pipelines, that's not included. If it's a SaaS product and they're doing some production operations, that's not included. So there's all sorts of things that are not included that are very necessary things that need to be done, but they just don't go into the estimation because we don't estimate the time for those things and features. We don't need to estimate it for work factors. Those have to be very much together. So this number then here, the 7.2 in this case, is just some simple math. It's the 36 days remaining less any vacation times that and times that to come up with that. So that's how those things are computed. And then they're summed and aggregated at the team level. That's what you see over there. And then the various teams, ECDs available, are summed to come up to that 365. That's the same as this number over here. We have some additional team level metrics as well. The ECDs required that are assigned to a team. So as you recall on the features, we assign features to teams. So team B gets 20, and those are aggregated across that list and are the ECD required. And so we look at a team-based delta and a team-based load, which is the ratio of required to available. You can see this one team F is heavily overloaded. And so we'll have to do something about that, either remove some stuff that team is doing and potentially transferring it to other teams as well. The reason we look at it at the team level is sometimes teams have real specialties, and it's a fair bit of overhead to move someone onto that team, not onto the team, but rather to have them do that kind of work that that team is known for. And so it's something, you have to consider when you're doing this. And then you get the totals over here. Our total availability is 97%. Total vacation was 6 days. The total work factor added is 11 days. That's somewhat similar to the 10.1, but the 10.1 also takes into account the 6 days of vacation that are removed as well. So the 10.1 is the 365 divided by the 36 days remaining, not just the straight sum of the work factors. See, we have 30 developers across these teams, and therefore the average work factor is 0.37, and we're burning, therefore, 55 ECDs per week amongst these people. The sum of the ECDs required, again, that's familiar. That's a double check on this number over here. And the overall delta, again, which is the same as the delta, and the overall delta percent, which is the same as that. So those all come together. Is some teams, if we say dive into team F that's heavily overloaded, we see only 2 team members with incredibly high work factors. That's taken from reality. You know who you are. 1.1 means times 8. That means they're doing 8.8 ideal hours of individual contributor coding work against features on this plan per work day. So that's what they're actually tracking to. So supercoder territory, obviously. Important to note that doesn't have to all happen. You don't have to do all those 8.8 in every workday. You could do less during the work days and then do a binge on the weekend. The weekend kind of gets averaged out and it looks like a bigger per workday number. So it really, and we don't care if you do that during the day, if you do that at night, if we do that on the weekend, if you do that on your statutory holiday days, it doesn't matter. All of that stuff will increase the work factor. And again, I just need to emphasize that, lower work factors, like you've got a 0.2 over here, the lower work factor, it's not a value judgment in any sense whatsoever. This is a team lead. They can't put in a big work factor. This Dev 14, they may be doing a lot, being called upon a lot for their expertise to triage and debug field-based problems, right? There's maybe someone else with a lower work factor because they're an intern, for instance, and we compensate for the fact that they have to ask a lot of questions by that, like they're not doing work when they're doing that, so they're low as well. Or you might see other people say, here's a 0.1. Perhaps this person is an architect and they do a bit of coding, but they also help out a lot of teams figure out how things should go. So some of our most valuable people might have very low work factors as well. It's not a value judgment, it's a measurement. It's a measurement that informs these numbers here and tells us if we're going to reliably hit these or not. So as you can see, there's a tremendous amount of transparency that's present in this plan. All the data is all publicly available data in the sense that all of this data comes from Jira, essentially. But it's very difficult to dig through Jira to get it presented this concisely. So creating transparency is actually work, right? It's real work to create and maintain this level of transparency. But it's absolutely critical for all the stakeholders to know that they're engaged and for us to understand that we're actually on track and to create room for, say, some of these things like tech debt or business basics that otherwise get maybe squeezed if you're not doing this correctly, and quality over the long term will suffer as a result. And it also allows time for the features. We estimate the amount of time it takes to do a feature properly. So to do all the necessary tests, to refactor what needs to be refactored, those are by default what the estimates look like. Do we compromise that sometimes if we're really tight and we need to squeeze something in? Yes, that's the exception. That's not the rule. The rule is estimate what it takes to do a proper engineering job on the thing and then do that. So it's very empowering to the software developers as well that they have elbow room to do this tech debt reduction and the business basics type things. They have elbow room in the work factors to work on, say, the pipelines and improve those. They have elbow room to do the feature correctly. And I guess the price they pay for that is they do record their time, but not all their time. It's not, this is when I start work, this is when I stop work, I took a coffee break here. We don't ask for that level of detail. We only want dedicated individual contributor coding time on specific features. So that's obviously a fraction of their time. So it's not too onerous, and it really assists them from a software engineering point of view in being able to get their estimates better, both for their work factors and for their feature estimates. And we have postmortems that we conduct on the features, where we can see the time series of what was the estimate, how does the estimate change over time as work gets done, and you bring the team together and you go over those postmortems, and just the mere fact of going over those makes you better and better at estimating things. The plan is also very live. So what would happen, say, if we took Team D and we said, well, we need to move Team D to something else. So we'll wipe out Team D. Well, we're now at 89%. You can see the graph changed as well. This is looking uncomfortable, unlikely we're going to hit. If at the same time, say, we re-estimated this 20-day thing, it was much harder and bigger scope than we expected, and we change it to a 50-day thing, we can look at the impact of that. We're now at 98% of plan, right? So that's not good. And again, say if we did someone on Team F, say, one of these two people, they're burning out. They can't do that. They need 2 weeks of vacation. Both of these guys please take 2 weeks of vacation. We don't want you guys burning out. And now we're done. We're minus 12. And we can see here that those lines just converged very dramatically based on what happened. We took a little bump up here with the re-estimates, took a big bump down by losing a team, or if a dev quits, for instance, or by giving those people extra vacation. So let me undo that. Only it was so easy to undo things in life. There we go. Back to our 78% plan. So, and where do these things come from? These ECDs, remaining ECDs to date, we pull them straight from Jira. Jira has a feature called work logs. And in the work logs, you can track time, track ideal hours spent. And you can also re-estimate the work remaining in ideal hours. So we encourage devs to do that on as regular a basis as possible. And then we use a plugin in Jira, in this case called the structure plugin, that can add things up a hierarchy of issues. And then it produces a nice little concise report that's easy to copy that and paste that into here. So that's overall the plan. We manage quite proactively between start and decut. We almost create an artificial mania around hitting this decut date, even though there's a lot of time afterwards to clean things up. We really try to put an artificial mania on hitting decut. And everyone buys into that. Everyone understands why we're doing that. If it shows any danger, we will take action. We will move dates, or we will move features. After this date passes, when we do get into stabilization to validation, you're more in the back seat. You're observing defect arrival and departure rates. You're doing, some active management. If you don't see enough defects, maybe you need to apply more test resource to it, or have devs do some more of the testing. If you see too many defects in a certain state, you make sure to motivate the developers to do defect fixing as a top priority, because some of them might be working on next release items, kind of getting a jump start on the next release. Pull them back and make sure that you clear the backlog with a certain priority. But you're a bit more in the back seat as this goes on. Now, these numbers came from history, right? We have a history with this app. We know the ratio of coding time to stabilization time that is typically needed to drive the release blocker defects down to 0 and then to stabilize it afterwards. And we apply that past experience to the next release. Now, if it's the case that we actually get done sooner, there are no blockers, and we've only 60 days in, and then we do our validation in, say, 10 days, and that's 70 days total, we'll apply that learning to the next release. But we won't plan on that happening. We'll have to have observed it first before we plan on that going forward. What I can kind of guarantee is if you don't have this level of transparency, if you don't have a plan that looks somewhat like this, if you're not doing good capacity planning, really is what it is, then you have a sense, there will be a sense in the organization of an end date, and there will be a sense in the organization of the feature content by that end date. But it'll be a vague sense, and invariably dev will disappoint. They'll disappoint and disappoint and disappoint, and fingers will be pointed, and devs will say, well, we never committed to any of that. We don't know where those things came from. And you get dysfunction happening as a result. Plus, when the devs are apparently under-delivering, they'll get squeezed, and what will happen is the quality of the features will get squeezed, the tech debt will get squeezed, the business basics will get squeezed, the work factors will get squeezed, which means folks will do less of that pipeline maintenance work that's necessary. So all sorts of dysfunctions happen as a result. The first time you put a plan like this in place, and like I say, if there's a vague notion of dates and feature content, if you actually do this plan, you'll find that there's almost 3 to 5 times more work than you can possibly accomplish. And that's been my experience almost every time this happens. And so when you do this exercise, you then get actually a dose of reality. And now you can manage your company properly and remove all of those dysfunctions I talked about before. It's important to understand these dates are not commitments, they're target dates. If you do need to make a customer commitment, then you pad out the date further than your planned date, ideally, and you commit to the smallest possible thing you can commit to and go forward with that. You really don't like doing that, though, because as soon as you do that, it puts a pin in the plan. You can't move the date any further out than that, and this feature absolutely must go in. And so the whole plan kind of artificially revolves around this 1 or 2 pins that you've put in the plan. So in early days back here, you want to still keep it fairly loose about when the end date is and what the feature content is. And if you do make promises, make it kind of directional promises rather than more specific promises. Because back here, that gives you the freedom of still being able to move the dates. An important thing is, these are date moves. They aren't date slips when they're happening back here. A date slip would be if it happens here, right? That's a slip. These are proactive moves of dates that are going on here, where we've determined that the best release would be one that takes a little bit longer but has a bit more stuff in it. Now, as developers, we can be a bit agnostic about that. We can say, well, we don't care. Product management, you want more in it? The time has to go longer. Product management is free to remove things. So rather than moving the date up, another reaction could have been to remove features. And yeah, you'll get the feature the next release rather than this release. But that's not slipping a date. And you have to be careful to communicate that. That is proactively moving dates at the behest of product management. Like I say, slipping dates happen when dates move here or when this kind of end date moves because it's still the software isn't stable enough at that point. That would be slipping a date, and that would be a bad thing. So that's the Horizon plan. As I've mentioned before, I take this Horizon plan, I implement it everywhere I go, and it's a night and day difference that it makes to a software organization. When I'm interviewing for a new job, I describe this method, what I'm going to do, and the CEOs, the boards, they love it. They love that I'm going to put in that level of transparency, and they love that I have a very concrete method by which I'm going to achieve that. The biggest complaint owners of businesses have and general managers have is they lack the transparency. They want to be involved, but you can't give them this giant laundry list of things they can't possibly understand. You need something, that's still a little bit complicated, the plan, but it's something that you're capable of getting your head around and making real business decisions, real trade-off decisions inside that plan. That's what the business leaders want. They want to be a part of that process when we have evolving uncertainties going on of resolving those evolving uncertainties. So I can say very confidently that putting this in place has been very much responsible for whatever success I've had as a software development manager, and my colleagues who've implemented similar things, what success they've had as well. So thank you very much. Please download that plan. Please use it to your heart's content. Remember to subscribe and click the notify bell and like and share this video and share it to all your colleagues around. Say there's a great method of managing software projects that I've never done before. Anyways, thank you for your attention, and I'll see you next time.